Okay, this video is on midsegments, how to identify a midsegment, and then how to apply the midsegment theorem. So first of all, to identify a midsegment. So let's say I have this triangle, and I have triangle A, B, C. So we're going to say that this point, point D, is the midpoint of segment AB. So it cuts it evenly in half. I can mark those two segments, AD and DB, as congruent. I'm going to say E is the midpoint of BC, so I can mark those congruent. So a midpoint is taking two midpoints and connecting them. A midsegment. So a midsegment, I have connected point D and E. This is the midsegment. And there's a few important rules about midsegments. So one is that my midsegment is parallel to the side opposite it. So this is parallel to this. And the second thing is that it is half of that opposite side. So if this is x, this would be 1/2 x. It is half. So we can use this to find some values. So let's say I have this triangle down here. We'll do ABC again. So ABC, and then let's say D, E, and F are all midpoints. So I could draw a midsegment here, a midsegment here, and a midsegment here. All right. So now, let's say that I know that side AB is 10. So that's this side right here. Knowing that that side is 10, I can find FE because I know that this is half of that. So I would say, okay, FE is 5. Or I could also, if I know a midsegment, so let's say I know DE. Let's say DE is 6. I can use that to find the opposite side. So think for a minute, if this is 6, what is AC going to be? So it's going to be double that, right? It's going to be, this is half, so 6 times 2, that would be 12. There also sometimes might be variables in there. So I could say, for example, let's say we've done AB, we've done DE. Let's do maybe this one. Let's do DF. What if DF is x plus 1 and BC is 4x? Right, so this DF right here is x plus 1 and BC is 4x. If I wanted to find x, how would I set up an equation to do that if I know that this is half of that? So take a minute and think about it. Okay, so there's two ways. I could either say that DF is 1/2 of BC and plug in these values, or right over here, or I could say BC is twice DF. So either one of those works. If you don't like fractions, this might be the better one to do, to say that this is twice of this. My side is twice the midsegment. So now I just plug in. BC is 4x. DF is x plus 1. So if you solve for x here, what do you get? Right? We get x equals 1. And now that you know x, you actually can find the lengths of both the midsegment and the side. So if I know x is 1, what is DF and what is BC? Okay, so I'm going to plug in. So DF would be 1 plus 1 or 2, and BC would be twice of that, or 4 times 1 or 4. Okay, also again, parallel sides. So because I know that these are parallel, like this one is parallel to that, my mid-segment's parallel to the opposite side. Whoops, I meant to put just one there. This one is parallel to this, and this one is parallel to that one. So I can also use it to know that things are parallel.